So last week I sent out my Java Specialist newsletter, which I've been doing since 2000, so over 23 years. And I always try and send it out at least once a month, and my target is to do it in the middle of the month, but then I always have other things to do, so I normally send it out like near the end. And this one was, I found it quite interesting to do research on this one, because it's about putting code before super, which is in the preview feature of Java 22, JEP 447. And it addresses something which has been an issue in Java for quite a while, that you cannot write any code before the call to super. So if you want to, for example, check parameters or log some output, you weren't able to do that in the past. You wouldn't be able to check the parameters, and so you would first call super, and then super would maybe throw an exception. So what they've done is they've allowed us to have certain types of code before the call to super. And so that's what I wrote about. If you want to have a look, there's a link in the description linking to my newsletter if you'd like to read that and sign up for it. And the thing is, there are some restrictions as to what you can and cannot do. Now, when I saw that, I immediately thought, this is going to solve a particular problem that I saw a very long time ago. And this basically goes down to some code that I published in 2002, so 22 years ago, and it has to do with an insect. Now, the insect looks like this. We've got our print line inside the constructor that says inside insect constructor, and then I'm calling print details. Now, I probably don't need to tell you this, that you should never do that. You should not call methods within a constructor unless these methods are final or private. So you should do this, but we're doing it. So we've got this insect, it's abstract class, and it's calling this method. You could even call an abstract method. Now, as far as I remember, you can't do this in C++, but you can do it in Java with some interesting effects. So if I call print details, I'm actually going to call the print details on the actual subclass of insect. So if we have a beetle, and the beetle subclasses insect, in the constructor I've got the legs, how many legs this beetle has. Should be 6, but you never know. And I'm going to print out inside beetle constructor, and then I'm going to say this.legs equals legs. Now, what happens is when I compile this code, it actually adds implicitly a call to super over here. So that's always added, and I can't change that. That's always permanently there. And I can't put something before that. So I can't, for example, put that over here. Right? That's not allowed. Super has to be, always had to be the first statement inside our constructors. And in the bytecode, it's called invoke special, I think it's called, which is the super call constructor. So when I construct this beetle, I'm going to first call super without any parameters. That is going to call print details. We're going to print out the beetle has legs, and if legs is less than 6, we're going to print it ouch. And what you're going to find is that this wouldn't have been called by the time we call print details. And it doesn't matter that legs is final. Even if legs was not final, you would still first call the superclass constructor, and then that would call print details, which would call the overridden method, print details. All right, going back to our newsletter. So that's what happens. Now I've got a beetle test over here, and between two beetles, why does it not open automatically? Oh, I think it's a new version. There we go. Okay, so they somehow turned that off. Navigate with single click. Come on. Don't tell me they've changed this. They changed something here. There you go. Open. Something's wrong. Maybe I'll have to restart IntelliJ. Anyway, so we've got over here two insects, sad bug and happy bug. And the sad bug is constructed with 5 legs, and the happy bug with 6 legs. Of course, the beetle is supposed to have 6 legs. So let's run this beetle and see what comes out. And of course that super shouldn't be. Oh, okay, so this is now. So this needs to be run with Java 22 preview, and I think I'm running the wrong version of IntelliJ. So let me quickly restart and run this with the correct version of IntelliJ, which is the one that the very, very latest one, which happens to be IntelliJ 2024 dot something, 2024.1 or something, and that will hopefully now work better. Let's get it up the zoom a bit to make it 150. There we go, and we'll try and run it again. So hopefully this is now going to be working correctly. And IntelliJ has to now try and keep up all the time with Java versions. It's become quite difficult because they change every 6 months, and in substantial ways. So that is quite challenging to do. All right, so here we've got our no class def found error. Okay, so let's try and rebuild that. This is a live stream. Of course, it's not going to work. Release version 7 is not supported. Where am I seeing version 7? Come on. Open project settings. Okay, we want to, for the module, we want to use dependencies, Java 22, that's right. And the sources should be statements before super. So somewhere along here, it's picking up the wrong version. Oh, I think what I might have to do is to delete the generated classes. Let me just do that quickly. So, that's the wrong place. You can see this is a live stream. Things didn't work the way I want them to work. Okay, delete the classes. Right. Hopefully this will run now normally. Okay, so it worked properly, and this time what you see is that both beetles have 0 legs. Okay, because we first see inside insect constructor, then it does it calls that that code, and then after that it says print details, and we see we don't have any legs yet because we haven't set the legs yet. If we called print details afterwards, we would see that they do have 5 legs and 6 legs. But if you just call it like that, we won't see that information. All right. So if we go back to the newsletter, the next part would be that it can get even weirder, right? And this is this is some code that many years ago one of my colleagues saw this problem and he said, "Hey, what's going on here?" And it's very weird because what we're doing here is we've got a nested bug. Inside here, we are constructing inside the constructor a new complex bug. The complex bug is a private inner class. So it's a private inner class with a nested bug, which extends insect. Now there's an implicit handle from the complex bug object back to the outer object. That's how we can get the wings. So the wings are, I've just deleted the wings. Let's put the wings back. Okay, there we go. So it's a pointer back to the wings, and when we run this code, we'll see that the wings will be printed without any problems. It's just 2. Okay. However, this wasn't always the case. Before we had Java 1.4, and I do remember that far back, what they would do is they would over here add a constructor, and the constructor would look something like this. It would take as a parameter a nested bug, this $0 or something like that, and then they would say this $0 equals this $0. Okay, so they'd have a field inside here for this $0 inside complex bug, and then what they would do is when you saw wings, they would then use accessor methods to access the wings field from outside. All right, so that's how it worked, and of course, by default, it would do this. It first call super, which means that this hasn't been set yet, and so when you called, for example, this $0.wings, which is implicit in the code, but here I'm doing it explicitly, we would then get a null pointer exception because this .0 hasn't been set yet. Right. So that's what used to happen in Java 1.3 up until 1.3, from 1.1 up to 1.3. So let's delete this again, this constructor, and we're going to compile this with Java 1.3. Now you need to get into a bit of a time machine to do that. And so Java 8 will do it. If you say Java 8 minus minus source 1.3 minus minus target 1.3, and you say nested bug.java, oh, it needs to be, I think, just one minus, not two minuses. That's minus 1.3 and target 1.3. Maybe just without the source. Let's try that. Come on. Oh, okay. I need to say Java C, not Java. Okay, so try this again, but this time use Java C, not Java. Okay. Right. So it's compiled. Java 9 won't do that. So Java 11 won't allow you to compile with Java 1.3. It's an error, but Java 1.8 still allows you to compile with 1.3 source and target option. All right. So if I now say Java nested bug, and I'm actually running this in Java 11, you see this null pointer exception because the code has been written, the bytecode has been written to not to do the first thing, do super within the within the complex bugs constructor, and before setting this $0 equals the nested bug object, the outer object. And it doesn't matter what version of Java I'm running. If it's Java 22, it'll be the same thing. It's still going to give you that exception. So it cannot read the field wings because parameter 1 is null. Now, parameter 1, what they did was they added the option somewhere along the line that the parameters are part of the compiled classes. And I think it will work in Java 8. So if I say Java C minus parameters, I think it should show us the parameters as well. So if we run the code with Java nested bug, it just says null pointer exception without showing you what the exception is. But if you do it with Java 11, I think Java 11 will do it, or Java 20, Java 17. So Java 17 will say, it still says because parameter 1 is null. So I don't think it's actually stored the parameter names. And anyway, the parameter 1 is a generated parameter, and I actually think this is slightly wrong. Maybe it is correct. Maybe they have called it parameter 1, because what it's calling a synthetic method in order to get the wings parameter, the wings value. All right. So and if you take Java 8 and we compile it with Java 1.4 source and target, then it no longer had that mistake. And if you run it now, Java nested bug, and you can see it works perfectly. And if you look at if you disassemble the code, Java P minus C complex bug, what's it called? It's actually nested bug dollar complex bug, and we'll have to say minus private. I think minus private. Right, so minus private, and what we'll see here, we'll see the constructor. This is a private constructor that's actually being called, and it's writing this $0 before calling super. This invoke special is the call to super. So we're first going to go and put the field and then invoke special. Now, we have not been able to do that within Java up until now. Well, we still can't do exactly that. So we can't write fields. But we can now, in Java 22 preview, put code before calling super. So if you go, for example, back to our Beetlejuice, or back to our Beetle, we could have put super over here. Right? So we could first print out inside Beetle constructor, then call super, and then call this.legs equals legs. But what we cannot do is we can't do this, which is actually what we want. We want to first set the fields and then call super. Now, what's interesting is if you look at a language like Swift, there they do allow you to do that. So you can say inside your constructor, you can first set the legs and then call super init. So you can do it that way around. And so there your code will work the way that you would expect it to work, where when you call print details, it's going to call print details with the fields being set already. So if I go to source main Swift and I call that code Swift, I think this is how I do it. I don't use Swift very often. In fact, yeah, there you go. So you can see that here it actually does what you would expect it to do, where it goes and first sets the legs and then calls a super constructor. So we see the beetle has 5 legs and then the beetle has 6 legs, not 0 legs both times. All right. So as I said, the actual bytecode has allowed a code to run before the call to super, but in the Java code we weren't able to do that. But we can now have some code before. And so what we've got is, here's the Beetlejuice. Now the Beetlejuice is a slight variation on the beetle, and what we can do is we can print some information before the call to super. We could even check that legs is not is bigger than 0. So we can say if legs is less or equal to 0, then throw, although 0 is probably a possible number, less than 0, throw new illegal argument exception. So we could do something like that. So we can do put code before the call to super, but we cannot set the legs. So this is unfortunately something we can't do. We also can't print out this legs. We can't say print out this. We can't even call print details from there. So we can't say print details because that would require a pointer to this. All right. So there's no way of getting hold of this, the pointer to this, before you call super. And they did this for very good reasons. But it does mean that this particular problem doesn't get solved. So if you're working with code where they're calling methods from the constructor, ideally change what you're working with. Don't do that. So that's a really bad idea. And you'll see if you try this out, the Beetlejuice test, you'll see that it's still the same as before, except there's more output. You can see that the legs equals 5. Going to call super now, legs equals 5 inside the insect constructor, but then the beetle still has 0 legs. Now, one way that one could get around all of this is to do the following. Let's get this back to what we had before. I don't want to change anything. Okay, that's not a idea. So one thing we can do in order to get to solve this problem is we've always been able to put code before super in a very sneaky way. So what you could always do is inside super, if the superclass takes a parameter, you could inside super call a static method. It won't work in this case because insect's constructor doesn't take a parameter. But if we added one, let's take a public or make a protected insect. This is a sneaky one, Boolean sneaky. Okay. If we have something like this, and that just simply calls this, right? That calls other constructor, then we would be able to call that from the subclass in a very sneaky way, and also call a method to do some things. Now we still can't access this, but there's a sneaky way of doing it. So what we could do like this, we could subclass that and say, let's implement this saying a very sneaky insect, and we're going to actually subclass the, so we're going to say super, we're going to have int legs inside here, int legs, and let's make a field for that. All right. And we can say super, and we're going to have sneaky save of the legs. So we can call sneaky save. Sneaky save has to return a Boolean, because that's the parameter that's going into the superclass, and we're going to pass in the legs. Right? And then inside here, so what I'm saying is you can actually call methods before calling the superclass. But they've got to be static methods, and you don't have access to this. So it's the same problem as before. So you can't, for example, say this comment x. That's not accessible until the superclass constructor has been called. And then here, what you could do is you could try and save the legs in some way, which I'll show you how to do that in a moment. But for now, let's just keep this as it is. The thing is that this only works if we have a constructor which takes a parameter. If the constructor doesn't take a parameter, then we can't do this. So, and if we are able to change the superclass to have another constructor which takes a parameter, we might as well go and and change it so we don't do this crazy code, right? To not call a method from the constructor. So so that's not really a good solution. So I'm going to delete this again. It's not the way I would want to do it. And let's delete this very sneaky insect again as well, because it's not, even though this works, it's not as widely capable as what we're going to do now. So another way to do it is to sneak it in with this new feature, JEP, what was it again? JEP 447 or something. Yeah, JEP 447. So we can sneak it in with that. And I've done that with my Beetle bypass. Now the Beetle bypass is storing the legs as a temp, as a thread local. Now the reason I did it as a thread local is I can't use a static, because a static would potentially cause clashes of two threads at the same time construct these objects. Whereas a thread can only construct one object at a time, one thread. So if you make a thread local, you're going to be safe with that. And basically what we do is we, when we construct this, we first call save legs temp. Save legs temp is a static method, and it sets the value of the thread local equal to legs. And then once we've done that, we're going to call super. Then we print out inside Beetle constructor, and then we set legs equals to legs, which is the final field over here. And very important at the end is to remove this legs again. So this is only a temporary thing whilst we are busy constructing in order to save that information. And then wherever we access legs, we would now use a legs method. The legs method over here says if temp legs get is not equal to null, which means that the only time this will be true is if we are busy calling this whilst we are still in the superclasses constructor. Because once we've finished this constructor, we have set legs equal to legs, and we've removed the temp legs. So temp legs equals null. This is why we have to remove it, so we don't get confused inside that method. So if the temp legs get is not equal to null, we return temp legs.get. So we could put this into a local variable if you want to. Let's put this into that's going to be the value. Okay. So if it's if temp_legs.get is not null, we return it. Otherwise, we return the legs. So we can probably do over here ternary if else. I'll do this. Okay. There we go. And then we can inline this. There we go. So return objects require non-null else. It's if this is non-null, we return it. Otherwise, we return the legs. Okay. And then and so over here in the print details now, I'm using the string templates. These are very cool. So we can just say the Beetle has, and then / open curly braces and legs. That's the call to the legs. and if legs is less than 6, we print out ouch. So this now works quite nicely if I run the code. Of course, as I said, you need Java 22 preview for this. Then we can see the output looks exactly like in Swift. That's what I really would have wanted to see from the beginning. It's a bit of a weird workaround to make this work. It is not ideal. Ideally, what you want to do is to not do this and to instead use use another framework, or which doesn't call methods from the superclass constructor. So ideally, this wouldn't happen. But if it does happen, here's a workaround. Well, one day, once we get to Java 22, or in fact, once this gets released, probably the next LTS release will be useful. So 25 or something will be the next one that we can use. But until then, obviously the best way to do it is to avoid this altogether. All right, so one thing which I thought I should do is to go through some of my newsletters and actually make a quick recording about it. I've got a lot. I've got hundreds of newsletters that I can talk about. And I'm sending this out on LinkedIn, on Twitter, on X, well, that's Twitter, on Twitch as well. I meant Twitch, and a private Facebook group as well. So let me know what you think. I'm quite happy to engage in comments. And thanks for watching. Appreciate it.